So good evening, Carolians. This is A Week Above the Clouds. It's a short talk about an astronomy field trip to Tidey Observatory in the Canary Islands, organised jointly by Liverpool John Moores University and the University of Liverpool. So every year, or at least every year that isn't a COVID year, we take our astrophysics students on an observing trip to the Canary Islands. The two universities, Liverpool John Moores University and the University of Liverpool, jointly operate an astrophysics programme, an astrophysics degree programme, and also a physics with astronomy degree programme. And it's those degree programmes, students from those programmes, who come on this field trip. And for those that don't know their geography, that's where the Canary Islands are, just off the coast of Morocco or Western Sahara. So we have a little archipelago. There's Tenerife in the middle. There's La Palma further to the west and Gran Canaria further to the east. So let's blow up Tenerife a little more. Right in the centre of Tenerife, we have Tidey, Mount Tidey. And the red circle there indicates the extent of the caldera. The caldera isn't quite complete, but the red circle, the red ellipse, gives you an idea of the extent. And observatories are usually best placed on the caldera of, in this case, Tidey. In the case of La Palma, again, the observatory there is on the edge of the caldera. So the rectangle shows you where the observatory is located. And just for reference, let me show you what Tidey looks like at night. You can see all the tourists are confined to the coastal areas, and the middle of the island stays nice and dark. Not only is the light pollution confined to the coast, but also there's a very convenient cloud layer which tends to separate the lights underneath the clouds from the observatory above the clouds. So let's have a closer look at the observatory itself. Let's zoom in just a little bit further. There's the observatory, about a dozen or so telescopes. Tidey Observatory is mainly a base for solar telescopes. So there are three big solar telescopes called Themis, and the Vacuum Tower Telescope and the Gregor Telescope. There's also a couple of smaller visible telescopes and one infrared telescope. But I'm going to be talking about taking students to the smallest of telescopes, which is effectively a teaching telescope right here in the middle of the observatory. We'll zoom in a little bit further. There's the dome that we use. There's a small workroom next to it and a little area out the back for doing some naked eye stargazing or some astrophotography. That's what Mount Tidey looks like. There's Mount Tidey itself in the distance there. And you can see that there are basically no trees at this altitude. We're at about 2,500 meters or about 8,000 feet altitude. Not quite as high as the peak of Mount Tidey itself, but still quite a height. The air pressure here is about 75% of sea level pressure. So you do notice it when you're walking around. Here's a little panorama to show you what the view looks like. As is common with all of these pictures, you'll notice that there's plenty of cloud around, but generally we are above the cloud and therefore that's not a problem. This is looking across at the edge of the caldera and the observatory is on the horizon. Perhaps you can't see it, those tiny little white dots are the observatory. And if I blow that up, you can again see the three big solar telescopes and another visible light telescope, and the telescope we're going to be using is a small one that's just peeking over the edge of the caldera here. So this is the dome we're using. The telescope is in here, the workroom to the right. There is some limited accommodation on site. That limits how many students we can take. We can take basically 2 or 3 or 4 staff and up to, but not more than, a dozen students, simply because the limitation of the dormitories that are on site in the observatory. In the distance there, beyond the dome, in the distance, the island you can see on the horizon is Gran Canaria, about 100 kilometers away. This gives you a good view of the dome itself, the workroom and this area out the back, which is a very useful area just to do naked eye stargazing, and that's where I do any astrophotography that I do if time allows. Sunset is around about 9 to 9:30 in the evening, and sunrise is at about 7 o'clock in the morning. So the clocks are rather weird because although Tidey or the Canary Islands are further west than the UK, the clocks are further forward. And so the middle of the night is actually nowhere near midnight. The middle of the night is actually somewhere around 2 or 2:30 in the morning. But as soon as the sun goes down, we get into the dome, open up and start to either take some flats if we're doing some photography, or on the first night we actually get the students to do some observing through the telescope. So this is the telescope we use. It's the so-called Mons telescope, called Mons because it was acquired from Mons University. It's quite a large telescope in terms of its mass. It has a 1/2 meter mirror. It's a 20-inch mirror used usually in the Cassegrain mode. It's on a German mount, so it's a very massive telescope and has a rather large massive counterweight. So one of the first things students have to learn is how to move the telescope in the dark without banging their head on either the telescope or the counterweight. In most of these images, of course, I'm taking fairly long exposures in very low light, so the telescope will quite often be sharp and the students will look very blurry. Most students in Liverpool do look blurry, but in this case it's because of the photographic conditions. So there we have the 20-inch Mons telescope. It's a teaching telescope in the sense that it used to be a research telescope many years ago in its original home in Mons University, but then was moved here on site to act as a either use by the public or use by students telescope. It is not computerized, it is not automated, it is not go-to. We want a telescope that's as manual as possible so the students can really understand how to point a telescope at an object before they get used to the idea that, well, there are telescopes that will do that for you automatically. So we usually have the students working in teams, and they are tasked with the idea of how to figure out how to point an equatorial telescope. For just about all of the students, this is the first time they've ever used a telescope on an equatorial mount. They may have used other telescopes back home, but this is the first time when they're getting used to the idea of calculating hour angles and declinations to work out where objects are in the sky. We usually want them to work in teams of 3 because although these pictures were taken in red light, they often work in the dark to preserve their night vision. And for a telescope of this size, we often need at least one person to move the telescope, one person to make sure that the right ascension and declination locks are applied or released at the right time, and often one student just to make sure the telescope is moving in the right direction. Notice that here one of the students is reading the setting circles. We want students to understand exactly how to point a telescope in the sky, to understand celestial coordinates, and hence to understand how you use setting circles to make sure that the telescope is pointing at the object of interest. Here's another view giving you an idea of the idea that students have to work as a team of 3. They have to communicate with each other and they have to know exactly what they're doing, even if they can't see each other in the dark. There's a workroom next to the observatory, and where possible we split the cohort of students into 3s. So for instance, in this particular case, 3 students are working on the telescope and 6 students are working in two teams of 3 in the workroom. So it might be that one team of 3 will be planning what they're going to be doing next time they use the telescope. It could be another team of 3 will be looking at the data they took when they last used the telescope. It might be that they have 2 or 3 hours of telescope time and then all the teams rotate. So throughout one night, the teams might have 1 or 2 or possibly 3 goes using the telescope, and for the rest of the time they will be planning their observations and having a look-see at those observations, even if they don't do the full data reduction until they get back to Liverpool. So what do the students actually do? Well, to start with, after we've dealt with all of the health and safety side of working in the dark with a very large instrument, what we want them to do is to decide what object they want to point at, calculate the coordinates of that object by processing the coordinates themselves. They're told how to do that in the theory modules of the degree program. So we want them to calculate the precession from the year 2000 to the year that they are actually observing in, and then use the setting circles on the Mons telescope to point the telescope at the object, preferably to an accuracy of a few arc minutes. So after they've looked through the telescope on the first night, just to get a feel for instance, what Saturn looks like through a half-meter telescope, after that, then the students will decide what they want to do, what they want to study for the rest of the week. For instance, they might choose to look at star clusters, and they might take images with a CCD camera of a number of different star clusters, perhaps open clusters, perhaps globular clusters, and using different coloured filters, they will generate Hertzsprung-Russell diagrams and try and deduce, for instance, the age of the cluster. They might look at planetary nebula and look at the planetary nebula with different filters such as hydrogen alpha or oxygen 3 to look at the different structures that are revealed. Another alternative is they might be looking at, using a hydrogen alpha filter, they might be looking at the star formation regions in the arms of spiral galaxies. Other students might choose to do a project involving a variable star, and during the week they might look at the variable intensity of a star and map out its light curve. So there are various options that the students can go for, and it's up to them to decide which particular project they want to actually work on. They will take the data during the week and they will write it up as a project when they get back to Liverpool the following semester. I try and encourage them not to spend all their time in the workroom analysing their data or thinking of the next observation. I do encourage them to go outside and just lie down and admire the dark night sky. Or if they have a camera, I usually take a tracker with me, and so they often use my tracker to take images of the sky. Here's some images that I took of the Milky Way. This was with a wide-angle lens, so this is from the region of Cygnus at the top through Aquila and Scutum and Sagittarius and Scorpius down in the bottom right here. There's Antares right at the bottom. And of course we have the centre of the Milky Way, a little bit difficult to see from England because it's so low in the sky, but at a latitude of 28 degrees north, much higher in the sky as seen from Tenerife. If I switch lenses from an extreme wide angle and switch to an 85mm lens, then a lot more structure is visible in the Milky Way. And we can see a number of different nebulae. We have M16 at the top, the Eagle Nebula. Then we have M17, the Swan, or the Omega Nebula if you prefer. And then we have the characteristic colours of the Trifid Nebula and the Large Lagoon Nebula. And of course lots of structure in the dark dust lanes of the centre of the Milky Way. Here's a little mosaic that I tried just to see what could be done from these nice dark skies, and although I normally use raw images and stack them and process them with darks and flats, in this case I decided just to see what you could do from a nice dark sky site. So this is a series, this is just a mosaic of JPEGs taken with no darks and no flats. And you can still get some very nice images here. 4-minute exposures still gives you a very nice mosaic of that chunk of sky. This is the Antares and Rho Ophiuchus seen in a little more detail. I've now switched to a 135mm lens, And there's Antares sort of embedded in this nebula. There's the M4 globular cluster right next door to it. Rho Ophiuchus, which gives the name to this particular molecular cloud. And you can see that the Rho Ophiuchi cloud complex is a rather large thing, including not just the nebula that is illuminated by Antares and by Rho Ophiuchus, giving you the beautiful colour contrast, but also there's lots of dark nebula in this area as well, giving you a nice composition here. Of course, there's always the chance of doing star trails. In this particular case, I used a relatively wide-angle lens, hence it looks a little bit distorted in the foreground. It's a little bit different from taking star trails in the UK, simply because at 28 degrees latitude, Polaris is of course a lot lower, closer to the horizon. And so you get this rather nice effect of Polaris being relatively low compared to foreground objects. By taking a series of images, we can either add them all together to get a static image, or we can add them together to give a movie of the stars rotating around Polaris. There's an almost daylight quality to this image because, of course, the observatory buildings here appear to be bright white and the grass appears to be green and the sky appears to be blue. But this is simply because I took this particular shot on a night of the full moon, and so all of these objects are illuminated by a very bright moon and the sky is not truly black. If we take a series of field trips, and it might be that field trips back to back for different students stretch over 3 weeks, it might be that full moon occurs in there somewhere. It's of course preferable not to have a full moon when you're trying to take other objects, but it doesn't necessarily impede the work that's being done, especially if narrowband filters are being used for the students' projects. On the right here we can see a couple of the solar telescopes. There's Gregor and there's the Vacuum Tower telescope. In the extreme right you can see just at the edge here a flat building. That's the dormitory that the students use during the day, and that has a limit of the 12 students. That dictates how the structure of the field trip actually works. Sunrise somewhere around 7 to 7:30, usually above a spectacular cloud bank. The students and the staff, of course, will sleep during the day soon after sunrise. The staff often have a job to do before the next night's observing. It might be changing the eyepiece to changing to a camera setup. It might be changing the filters in the filter wheel. There might be a number of different tasks that need doing. It's possible that the telescope might need rebalancing, for instance. But generally speaking, we sleep during the morning, perhaps through lunch. In this particular case, breakfast is, for me, quite often in the middle of the afternoon, with a beautiful view of Mount Tidy in the distance. The students also get the use of the Liverpool telescope on the neighbouring island of La Palma. There's no need to go to La Palma because the Liverpool telescope is the world's largest robotic telescope, and even though it's relatively close, it's still used robotically. So the students are allowed time on this telescope. 80% of the time of the telescope is used for research, 20% of the time is used for schools or university students. So we allocate our students a few hours of time on the Liverpool telescope so that they can augment the data they're taking on the Mons telescope by taking a little bit of additional additional data on the Liverpool telescope as well. And again, it's up to them to decide how they're going to use the hours that they have on the Liverpool telescope, how they're going to subdivide their time and decide what they are going to take, whether it be images or spectra or light curves or whatever it is that they want to augment the data that they've been taking during the week with the Mons telescope. And although most field trips do go to plan, occasionally even the best laid plans do go a little bit awry. Sometimes there is some high cloud during the day, and usually that clears during the night such that we are looking down on the main cloud bank that is covering the coast of Tenerife, but occasionally some high cloud can still persist. And occasionally there's a little bit of a breeze that means that we can't always observe for all of the 10 hours between 9 p.m. sunset and 7 a.m. sunrise. Generally speaking, we don't lose much time because of cloud or because of wind, but we can't guarantee that we necessarily get 7 clear nights and 10 hours per night. So we don't necessarily get 70 hours of observing time, but most field trips we do get pretty close. The other times that the best laid plans sometimes don't quite work out is one particular year I found that this undergrowth, although it looks rather pretty in this particular picture, this undergrowth actually is very rough and very prickly. And I didn't realise that until I accidentally sort of half fell over and put my hand down to stop myself falling. And I put my hand in this and realised that, yeah, it is actually rather scratchy. And that does look bad. It's not perhaps quite as bad as it looks. It didn't actually draw blood. It just produced a lot of very interesting grazes. And rather curiously, many years later, I still have a little bit of a mark on my forearm where those scratches dug in. So it was a little bit painful, but not the end of the world. Actually, worse, as far as I was concerned, is the fact that some plans have been delayed simply because either Ryanair or EasyJet sometimes are a little bit unreliable, and although it should take 4 and a bit hours to get to Tenerife, sometimes our returns are delayed. In this particular case, this was the worst case I remember. We were supposed to fly back to Manchester. Sometimes we fly from Liverpool, sometimes we fly from Manchester. In this particular case, we were supposed to fly back to Manchester at 8 p.m. And as you can see from the top of this departure board, the flight was actually delayed for 8 hours, and we didn't actually leave until the early hours of the next morning, about 3 or 4 o'clock the next morning. And with a 4-hour flight, that means, of course, we get back to Liverpool rather late. So it made the next day at work rather tiring. But then, of course, the best laid plans sometimes do go awry. So overall, it's an absolutely fantastic experience. It's interesting to see how the students change from being complete novices and not knowing which end of a telescope to look down at the start of the week to being genuine astrophysicists by the end of the week, deciding what it is they're going to do, how they're going to plan their observations. And it's interesting to see just how much the students appreciate their time at Tenerife under beautifully dark skies during their time when they spend a week above the clouds. Thank you for listening.